I think mocks are used way too much. Many projects have normalized the use of mocks to a point where they have become a staple when writing tests. There are tools that do nothing but generate mocks. There are code bases where mocking makes up the majority of test code. All the while, mocks only ever enable us to test less with more effort. I believe they are often used carelessly and without real need. That's why I want to explore their origin and propose a way to avoid them in this video. First, let's look at an example to understand where mocks come from. Here we've got a function that is used to verify user credentials. It first checks if a login attempt limit has been reached, then queries a database to see if a password hash is available for the given username, and finally applies some sorting and hashing to the given password to see if it matches the stored password hash. The implementation details of the login rate limiter and database will be ignored in this video. To ensure that no developer accidentally breaks the password verification, we want to introduce a test for the verify credentials function. For this example, we'll assume that the login rate limiter and database are well tested elsewhere and won't bother testing them again. We don't want to test other parts of our program here, so we'll have to find a way to skip these sections of our code in the test. A common approach is to use dependency injection, so that we can replace the parts of the code we don't want to test with mocks. We can do this by creating a struct containing fields for the implementations of the soon-to-be mocked code. We'll place the implementation of the rate limiter into a separate package for clearer separation. Similarly, we'll also move the implementation of the database. Adding a constructor helps avoid misuse of a new struct. Now we can turn our verify credentials function into a method and start thinking about how we can mock the rate limiter and database. We'll use a tool called mockgen to automate the tedious task of writing mock implementations by hand. This tool only mocks interfaces, so we'll have to abstract our rate limiter and database structs into interfaces. Now we can finally generate two mocks, which will be created in separate packages. We have now finished preparations and can begin testing verify credentials. Firstly, an instance of a credentials verifier is created using the two generated mocks. Then we must tell the rate limiter mock what to do when a call to its method occurs. We'll simply return false to avoid the rate limiter getting in the way. Similarly, we must tell the database what to return when it is queried for a password hash. Here we'll return a pre-computed hash against which we want to test the sorting and hashing code of verify credentials. With the mocks prepared, we can call verify credentials and ensure that the credentials are accepted. We've now reached our goal of testing the sorting and hashing code, but we've generated a lot of code on the way there. We have written 3 new structs and constructors, 2 interfaces, introduced a tool for code generation and generated 2 mocks, just to test one function. Let's try to take a step back and think about how we could have approached the task differently. When we think about what we actually want to test, we'll find that it's mostly these 2 lines of verify credentials. When we recall the assumption that the rate limiter and database are already tested elsewhere, this is the only interesting code left to test. Realizing that, we could simply extract this code into a separate function. To avoid white box testing, we can also move this function into its own internal package. The test now becomes very straightforward. You might now think I'm cheating, because the second test is not testing verify credentials fully anymore. The test setup using mocks is potentially able to cover all of this code, while the second test only covers these lines. I believe that there is a significant difference between the rate limiting and database related code and the sorting and hashing algorithm. The latter implements business logic that is specific to the application, while the former only calls other units of our code which are already tested separately. In the second test, this integration code and the business logic have been clearly split. This made it easy to test the business logic, but left the integration code untested. Go's default testing tools and the most common test frameworks of most programming languages are designed for unit testing. The definition of unit is vague, but it is clear that unit tests are supposed to focus on separate units. When you get to a point where you are testing code that contains units you already test on their own, you are not writing pure unit tests anymore. At this point, you are misusing a unit testing framework for integration tests. Automated integration tests require the use of technologies that are tailored towards your specific application. They are often performed using a compiled program. For simple CLI tools, shell scripts may suffice. The Robot framework is an example of a more advanced testing tool, and for specific domains like web applications, specific tools like Selenium or Cypress exist. Creating a good test harness for your specific project is no easy task, but it is the right step towards more extensive tests. It will help you build stable software more than mocks ever could. To recap, here's my advice on how to avoid mocks. First, try to identify clearly which parts of your code contain test-worthy business logic. Then separate it from integration code by placing the business logic in separate functions or even separate packages. And lastly, abstain from testing integration code using a unit testing framework. If you want higher test coverage, think about introducing integration tests.